Good afternoon, everyone. Welcome to the IRT and IES webinar this afternoon. I'll just give you a little bit of detail as to where we are and how these things generally run. We have got myself, Stewart Little. I'm the CEO of IRT Surveys. I am sitting in my office in Bonnie Dundee. And over in Dublin, we have John Gleeson from IES. Say hi, John.
Hi, everyone.
Hi, John, thank you very much for joining us today. I really very much appreciate your participation in the webinar today. The point of today's webinar is to go through what you can do with energy surveys and just introduce IRT and IES to those who haven't seen it before. So if you do think it's weird, you're sitting in your office listening to this disembodied, strange Scottish and Irish combination, please spare a thought for us because we're all alone talking to ourselves in two rooms, so it is all a little bit bizarre. So hopefully you can all see my screen okay. Hopefully it's full screen and you are all connected. Without further ado, I shall show you a slide. Here we go, let's go full screen. Okay, IRT surveys, just by way of introduction, it stands for Infrared Thermographic Surveys. This is a nice wee picture of our office in Dundee. We've been here for about 11 years, and we have offices all across the UK. The company itself comprises myself as CEO, Alan, my brother, as our technical director, Dave Jones, who's the author of Grand Theft Auto and close friend. Around the country, we've got these handsome lads. I have to say that because half of them are listening, who are running our offices and are your local representatives. We've also got a bit of venture capital behind us. We were in the Carbon Trust Incubator Programme. We're members of the British Institute of Non-Destructive Testing, and everything we do is CHAS and Construction Line approved and accredited. Today's webinar, as I said, it's all about energy. Our ethos is that if you can see more about your building, then you're going to learn more about it. And learning more about your building is going to enable faster, better decisions and help you get retrofits done and past your board or your clients. So what do IRT do? IRT patented technology back in 2007 that can actually turn the images, an infrared image, into a quantified image of energy. Now, without gathering lots of information, it's impossible. You can't just take a thermal image and say, hey, you're wasting 347 pounds. That can't be done. What you can do is say, look, I know this is a 3-bedroom semi-detached. I know it's in Manchester. I know it's made of brick and block. I know it's 18 to 21 degrees inside. I know what the U values are. And then from that baseline, we can add in our thermal data and say, you're wasting 18,000 kilowatts, 3.6 tons of carbon and 347 pounds. So what you're looking at on your screen in front of you, we call the software Envision. It's a little bit cheesy, obviously. It's energy and vision slammed together. The house on the left is an after. It's nice and uniform. It's got cavity wall insulation. It's double glazed. The house on the right is single glazed and it's got no wall insulation. And it's quite a dramatic image. We also stamp the images with what we call a carbon hot foot. If it's a big red foot, it's bad. If it's a green foot, it's good. It's really, really simplistic. The problem we see in the market today is everyone has got carbon targets. Local authorities are trying to hit 5–10% reduction per annum, as are the NHS. And you also have things like legislation and fines for utility companies. They're trying to comply with things like eco. You've got new things out there like the Green Deal. But ultimately, it's a very confusing market. There's lots of energy managers out there who've done easy things. They've changed the light bulbs, and they're now on to slightly higher hanging fruit and are sitting there thinking, what do I do? And how do I convince my boss I've picked the right thing? Everyone knows energy prices are going up, and we're trying to answer that question of where to start. So with IRT, again, you're seeing the losses, which is quite a nice, dramatic, compelling thing to show someone. But we're able to rank and rate your buildings very, very quickly. Be that a portfolio of commercial buildings, be it a university campus, or again, NHS hospitals and clinics. We have done something like about 250 schools, probably about 300 university buildings. Even in the last 2 or 3 years, we're noticing the market really pick up. Once you've got that data and you've actually benchmarked where you are today, you can start the journey. And this is kind of where IES come into play for us. We can give you a really rapid, very cost-effective portfolio evaluation that says, you've got 100 buildings, these 10 are truly awful, these 80 are actually pretty good, and these 10 are absolutely perfect. That's where IRT can be used to its maximum effect. We can give you things like a carbon diet plan, which you'll see in a second. What the diet plan allows you to do is interact with your fabric. So you get a really nice simple carbon dashboard where you can move little sliders. Now this website is called irtcarbondash.co.uk. You can have a play around. There's a house loaded there and there's an office building. You can flip between the two. You can change U values. You can change the boiler. You can change lighting. Click calculate. The speedometers will swing around to show you likely savings. This is all based on SBEM and SAP online. But you can also switch on the diet plan tool. And what the diet plan does is that basically you say your things like your EPC. Your EPC becomes dynamic, so you can pick up the current rating of that building, move it to what you would like to achieve, and click carbon diet plan, go calculate it. And our servers will go away and do thousands of permutations of SBEM for you and come back and say, okay, what you need to do is this, then this, then this. There are a fair amount of assumptions, which John and I will touch on as we go through today, but as a broad brush starting point, there's nothing faster and there's nothing cheaper than that on the market. What we ask of our clients, the one on screen is 33 separate hospitals and health clinics. Client generally gives us everything they know about the building. Even better if they can give us the past 12 months energy bills. That allows us to get a really good benchmark datum to work from. And we go away and we work out what they can do to fix it as best we can. But we are still making assumptions at certain places. So the IRT deliverable looks like what you can see on your screen today, right now. We'll go around the fabric, we'll take visual photographs, we'll take thermal images, we'll give it an EPC rating, show you consumption throughout the year, and again, go around the entire fabric, all the roofs, all the walls of every building you have, and then give you really simplistic, look, we think you can save money from your HVAC system, from draft proofing, from walls, roof, lighting, windows, and here's how much you could save if you upgrade, for instance, your walls to 0.2 or 0.3 or 0.15. We can break all that down in a report for you. You can then interact with that report online via the carbon dashboard and say, actually, I would like to do better than that. That's not yielding the savings that I would like, and go a little bit further. The whole point of the Envision is to allow you to quickly rank and rate that portfolio, which leads really nicely on to what IES do. And I'm not going to attempt to explain IES. I'm going to pass it over to John to do that. But the whole point of the IRT is that broad brush. Let's target the big wins really quickly. Yes, it is a little bit assumptive from the SBEM or Energy Plus or IES stuff that we use at the core of our software, but it does allow you to actually start the process, and 9 times out of 10, that's half the battle, is getting people on board to actually start the process. But as I said, it does leave lots of gaps and opportunities for IES to actually come in and do what they do. So John, I'm going to pass over to you, sir, and I'm going to stop talking and you can chat to John.
Thanks very much, Stewart. Good afternoon, everyone. I suppose, first of all, just a bit of background here. I'll just share this screen with you. Okay. My name is John Gleeson. I'm based in the Dublin office for IES, and I work there as a business development manager. My own background is as a chartered mechanical engineer, and what we do predominantly can generally be regarded as building performance modeling. And I use this slide quite a bit to try and visually show what building performance modeling is via this funnel. Building performance modeling is typically used in the design of new buildings or the refurbishment of existing buildings. And obviously, with such a large percentage of buildings being existing, that is obviously where the greatest potential for energy and carbon savings exist. What we do is we create a 3D virtual model. We populate that 3D virtual model with how the building is being currently operated by the building owners or occupiers. And we run a calculation for that location of the building over the course of the year, typically on an hourly basis, but can be brought right down to be run on an individual minute basis. That then allows us to gain a better understanding for the amount of energy the building should be using under ideal circumstances of operation. It then allows us to make changes, both operational and changes that require capital investment, whether it's the use of high performance building technologies, installations, or further design principles, to rerun the calculation and quantify the savings specifically to our building. So that's it in a summary, is that we want to try and use this technology to get to that optimum configuration. And it's key to point out that the technology in its current format has been thereabouts for the last 15 years and is widely used amongst various mechanical and electrical consultancy practices worldwide for a varying degree of analysis. The unique point of IES's VE Pro software is this integrated approach. So we mentioned there on the previous slide about a 3D model builder. Once you have that 3D model builder, you can complete your solar analysis, your light analysis, your energy, carbon, natural ventilation analysis, all in the one platform. And the results of the solar analysis and the lighting analysis can feed into the energy analysis. And I'll give a quick example of that. If you have a building that has some brise-soleil or is shaded by a neighboring building which is in close proximity, you could run a solar analysis and quantify the reduction in solar gain due to that brise-soleil or neighboring building. You could feed that result back to the energy analysis and quantify what effect the solar is going to have in terms of heating and cooling energy over the course of the year. But obviously the brise-soleil and neighboring building is also going to have an impact on the daylight levels within the space, which in turn will have an impact on the number of hours that artificial lights are in use in the building. So you can go one step further and quantify the number of hours that artificial lighting is in use and feed that back into the energy calculation. Obviously, the knock-on effects of the artificial lights being on or off on the heating and cooling plant within each room will also be captured in the analysis. So it's hugely accurate in terms of its results, and we'll be going through some case studies of that in some of the further slides. Stewart mentioned the use of SBEM and SAP for the point of view of energy analysis, and quite rightly said it's a good starting point to gain percentage reductions by the use of increased insulation levels or increased efficiencies on plant, etc. I suppose the limitation in the likes of SBEM and SAP and those types of calculations is that they use typically the national calculation methodology. So that is used to input the hours of usage of the building, which would also affect when the building is either going to be heated or cooled to a set point. It would also affect the number of occupants and their hours of operation within the building, and the hours of operation of the likes of computers and other small power devices. So while it's useful to get an indication, it isn't building specific. And I suppose in terms of investing in the refurbishment of any building, a client has a limited budget and wants to eliminate the risk that that budget may have been used more efficiently on different technologies. Sorry there, for some reason.
I think if I can add to that as well, folks, that's what we find as well, John. We find that all the time, is that clients are making decisions based on a batch of assumptions. Like they'll assume, for instance, if they drill a hole in a building and they find insulation at waist height, they'll assume it's everywhere. And that's part of the IRT and IES proposition, is that might not be the case. Sorry to interrupt you. I just want to add that little bit.
No.
John,
please do. As we're working through it, that's all very useful input, and that's I suppose the key is that what we're trying to do through this partnership is to remove as many of those assumptions with actual information of building specifics, so that any savings are specifically to your case. Obviously, we can get a better understanding using the visual elements as well, whether it's the likes of solar shading of the likes of external shading devices or the effects on daylight, etc. In terms of the results of the likes of energy, we can color code the results, whether it be on kilowatt hours or air temperature, etc. to the model. So this is an example of a 3D virtual model which has been run, and the results of solar gain have been demonstrated on the model. That could also be used for the likes of heating and cooling, energy consumption, etc. You can also get the likes of your solar intensities on each surface, and this might be useful to indicate the amount of power which could be generated from the likes of PV, and if you're going to invest in something like PV, that you are locating it in its optimum location on your building. Within VE Pro, the software has been widely used for naturally ventilated buildings and mixed mode buildings. So if you have a building that has a floor plate which is in line with that can work from the point of view of natural ventilation, you can test it and confirm the temperatures that you're likely to achieve within your building over the course of the year. And you can change different strategies and implement those virtually to again confirm what temperatures you're likely to have occurring in your building. And it's only then, as a building owner or a building occupier, you can ultimately make an informed decision. Am I willing to accept slightly higher temperatures for X number of hours in the year? And my saving, in terms of my financial saving, will be Y. So that's what the software is all, has been widely used and tested for on many, many buildings. Obviously, the likes of the inputs like artificial lighting are hugely important, and those types of calculations can also be taken place within the model. In terms of the heating and ventilation and air conditioning within buildings, you have total flexibility to model your building-specific system. So if you were modeling a heating, ventilation, or air conditioning system within SBEM, you would be limited to select the system from the drop-down menu. Within our software, you have full flexibility to, first of all, capture the system configuration, but also the operation of your specific building. And that's hugely powerful in terms of quantifying savings specifically to your building. The software can also be used if you're looking to maybe achieve some sustainability certification, whether that be LEED or BREEAM. And that might be something that might be useful to particular customers in terms of marketing their company through their building as being sustainable or low energy. Daylight is obviously hugely important in terms of buildings and how they operate. And within the software, you can see the impacts of your changes will have on daylight and on energy. And again, looking at the likes of daylight with energy, with carbon, is very important to ensure that ultimately a client can make an informed decision on what they're looking to achieve. And you can get those slices at a 2D level as well as 3D within the space. For the likes of naturally ventilated buildings, it's very important in an urban environment to complete some wind analysis to get a more accurate representation of wind pressure coefficients of different surfaces on site. And again, the reason you would do this type of analysis is to reduce the number of assumptions that are being applied to the model, and again reduce the associated risk in terms of possible savings not being harvested specifically to your building. I have a couple of case studies here which I think will be very useful to paint a more complete picture now that we've gone through some of the various modules within the software which are used for building performance modeling. The first is an Irish project, which is an office building, government office building. And here the software was used to quantify the effects of everything from insulation to brise-soleil to daylight to system analysis, and also on natural ventilation analysis to a large percentage of the floor plate. The reason this was done was, going back to my earlier point, was that although a government client, there was a limited budget for the project. And I think that's something everyone will be aware of, is that you could achieve zero energy or zero carbon on all buildings if you had an unlimited budget. But in the vast majority of cases, what happens is that there is that limited budget, and people want to get as close to zero energy or zero carbon on that limited budget, and then to understand what their ongoing running costs will be on their specific building. This building achieved 50% reduction in carbon reduction over the current building regulations benchmark. And this building has been designed 3 years prior to the introduction of the current building regulations. The second one is quite interesting as it involves a retail company, Wal-Mart in the US. What's interesting here is that Wal-Mart have an energy bill of $2 billion, which by any standards is a massive energy bill, and a profit margin seemingly of 3% or something in that region. And what Wal-Mart were looking to do, although it says there on the front of the Fortune magazine to save the planet, I think what's probably more of an accurate representation is that they were probably trying to improve their efficiency of their building stock. And again, big and all as a company of Walmart's size are, given a turnover of, I think, $360 billion a year, they still had a limited budget to apply to the refurbishment of their prototype stores. In this case, the analysis was of their prototype 195 store. So that's 195,000 square feet of supermarket space. This would involve, obviously, the refrigeration cabinets. It would involve heating, ventilation, air conditioning systems. It would involve natural ventilation through the openable doors. And they would also have a knock-on effect on their energy consumption. So what we initially did in this case was we had built a virtual model of the prototype 195 store, initially for a location in Dallas. We populated that store with how the systems were set up from the likes of the BMS system to operate. And we populated the number of customers that were within the store based on till receipts. The refrigeration cabinets, as I said, on particular aisles were populated into the model, as well as the effects of the stock within the store in terms of thermal mass. All of that was captured and run for the location of Dallas initially. What we have found through that analysis that the model was within 5% on gas consumption and was within 3% of electricity consumption. Once we had that, we then could populate the model with some more high-performance building technologies, add, say, doors, some simplistic refurbishments like adding doors to refrigeration cabinets, change of lighting. And the change of lighting was an important one because many people look at the saving on artificial lighting as apples with apples. So if you have a light fitting that is consuming 20 watts per meter squared of electrical consumption and also providing 20 watts per meter squared of heat to the space, and you replace that with an artificial light fitting that only consumes 10 watts per meter squared, people see that as a complete saving. And it is a complete saving of electrical energy, but there is knock-on effects on the heating energy consumption within the store. So that means that the likes of your boilers will be working to make up that additional heat load to the space. Now, I'm not for 1 minute saying it's anything other than positive to change those light fittings, but I'm saying to truly quantify the saving of the artificial lighting on the building's energy consumption, as opposed to looking at artificial lighting at an individual element level, it's only building performance modeling that can truly quantify that for you, taking into account varying weather variables, etc.
So I think that's very important. I think that's a really good point, John. It's important that, because we all see this in the marketplace where a lighting manufacturer will guarantee 20% of energy savings, but if you actually ask them to guarantee it, they suddenly backtrack a little bit and say, we might guarantee 12. And being agnostic about it, doing what you and I are doing, I think that's critical. If you're going to make investment grade decisions, you need impartial advice. And again, you've also got things like your slides here. It's really important that you look at how people actually use the fabric as well. And that's something that infrared can add into, because again, every simulation model out there, you've got to be careful that the building is being used as expected, because it's not the end of the process, but also that it is actually built properly. I've been in architecture and I've been in roofing, and I know that when you write something on a piece of paper to say, make my store out of X, Y, and Z, it very often isn't what lands on site. Architects will tell you that's what lands on site 10 times out of 10, but invariably it isn't. In my experience, it's about 50% likelihood that the building is built as designed. But John, I promise I will shut up again. I'm enjoying your Irish brogue accent here. It's like a
Yeah,
it's like
hopefully everyone is understanding me okay on that
it's
front. But the critical thing there is, as Stewart has said there, about first of all capturing that the inputs represent as constructed as opposed to as designed, and secondly that they represent the operational values of the building, because that is critical to harvest ongoing savings from the building, insofar as you can apply lots of high performance building technologies and passive solar design principles, etc. But if the building owner doesn't understand how to truly implement them, that is a lost opportunity, and obviously in terms of return on investment, it then causes that to be much higher than it should be. And that again is where the likes of the use of the simulation software can be used, in my mind, from cradle to grave, whereby it can be used to quantify the energy savings in the first instance, and then to make a decision on which technologies you're going to adapt to your building. And once those technologies have been adapted to your building, you could then use the virtual model for continuous measurement and verification that the systems are actually performing as per the design. So this can provide that building specific benchmark to ensure that you not only get your best return on investment at design stage, but that actually also sees savings in the ongoing operation.
I'll give you a quick anecdote as well there, John. We did a shopping centre in Scotland, and we did everything. We threw everything at it to calculate where this building and how it should perform and what the energy consumption should be. And it was miles away from what it should be at night time. And it turned out they'd actually hired a security guard who was scared of the dark. And he was on night shift. But what he did was switch on every single light in the shopping centre so that he never ever got a fright when he walked around a corner.
Yeah.
And that's real.
Yeah, and that hits on such an important point in terms of the building operation. Once you hand over the building and everything is set, how the building should run from the point of view of an optimum from energy efficiency, that is typically where it's handed over to the occupiers. And typically, occupiers will make changes like what Stuart said there, switch on lights in a totally unoccupied period, start to change temperature, heating and cooling set points. All of these things will have a big impact on your return of investment. And what the virtual model can do in that case is, if you're logging the data from your BMS system, you can overlap that with the results of the virtual model to really see when the building isn't running as per the design. So obviously there is manual calcs that could be done to say, oh, the artificial lighting is very high. But when you actually graph the two graphs over each other in real time, it's a lot quicker to find that, yes, this needs to be reset, or we need to speak to the occupiers on the use of the buildings and maybe educate them on what is the most efficient way of managing their systems. So again, it's very important to provide that input back to the building occupiers if you want the building to operate as an energy efficient building. Okay. So that's the last point actually I want to raise before I finish up was, all of our focus in the presentation up to this point has been on energy and carbon and return on investment. But another very important point which the building performance model can assist us in quantifying and ensure is being achieved in our buildings is thermal comfort. And that was a very important thing in Wal-Mart's case as well, where they would tell you very quickly that their priority, much more than saving energy and carbon, is selling tins of beans and peas, etc. And obviously, all of the research that they would have would show that people will purchase more if they're within a comfortable environment. And the software can be used to continuously quantify what all of these changes that will be made to the building, whether it's on daylight or on heating, ventilation, air conditioning, what effects they'll have on our thermal comfort and also on our visual comfort. And that is another very important point in a lot of buildings. That brings me just to the end of the PowerPoint presentation. You'll see my email address and the company website there, where there's a lot further information. One point to note in terms of if anyone emails me this evening or tomorrow morning, or that I'm off next week on annual leave, so please buy me a bit of time with getting back to you on any emails that come through maybe later this evening, but I will get back to you in due course. So I'll hand you back to Stewart, and thank you very much for attending our web conference today.
Good man, John. Thank you very, very much for that. That was like listening to a very relaxed, chilled out Bob Geldof to me, and I mean that as a compliment, sir.
Yeah, we'll have to meet in person at some stage, Stuart. Not quite as sophisticated as Bob, but it's an ambition of mine.
To be like Bob.
Yeah, if I can move up to that level of sophistication, that'll be seen as a success.
Good man. John, thank you very much for that. I'm just getting to the end of this slide. I don't know what I managed to start it again for some reason. The very last slide is just our logo to say thank you again for your attention, folks. I think we had about 101 people online there. We do these webinars every month. They're always on the last Friday of the month. They're always at 12:30. Next month, we have a guest speaker from the Energy Saving Trust. So that should be worth dialing into again. We always issue CPD certificates. You should automatically receive one if you've been registered and logged in and we have your contact details. If not, please, by all means, send us through your details and we will send that out to you. And John, thanks again for your time and thank you very much for dialing in, people. I hope you found it of interest and of merit. And if you've got any questions, please send me emails as well. It's Stewart@irtsurveys.co.uk, and that's Stewart with an EW. Or indeed get in contact directly with John. Guys, thank you very much. Ladies, thank you very much. And we will end this webinar. Thanks again for your time. Thanks a lot, John.
Thank you. Bye now.
Thanks, folks.